Hello, welcome to this video. Today we're doing this. So we need to simplify the following sum. So we have 1,000 terms here, and it's 3 over 1 to the 4th plus 2 times 1 cubed, 3 times 1 squared plus 2 times 1 plus 2. And then the same thing here, but it's a 5 here and a 2 here. And then it's a 7 here and a 3 here. And then up until 2,001 here and 1,000 here. So what we're going to do is, first of all, write this as in sum. So the sum will be going from 1 to 1,000. And if you look closely for the pattern, you'll see that it's like this. We have 2n plus 1 divided by n to the 4th plus 2n cubed plus 3n squared plus 2n plus 2. Now usually when you have these types of things, because it's such a ridiculous sum, you're obviously not going to actually evaluate term by term and then add them all up. Instead, what you're gonna probably have to do is somehow factor this and maybe do partial fractions or something. Usually it's partial fractions. Like 2n plus 1 usually is used at n as n plus 1 squared minus n squared, and then after that you'll have a telescoping series which you'll be able to easily evaluate. But let's do it step by step. So let's first of all factor this. You might notice that the way we can factor this is like so. We have 2n plus 1 at the top. Then here I'm going to write separately n to the 4th plus 3n squared plus 2, and then plus 2n cubed plus 2n. I didn't change the sum. I didn't change the sum. All I did was shuffle things around here a bit. And then this, you might notice that we can write this as n squared plus 1 times n squared plus 2. And this we can write as 2n times n squared plus 1. So indeed we'll be able to factor it. We'll have a common factor of n squared plus 1, as you will see. And now n squared plus 1 is a common factor. And you will see that this is the sum as n goes from 1 to 1,000 of 2n plus 1 divided by n. Now after we factor this, like I said, usually it's going to be partial fraction decomposition. And here notice, this minus this is exactly 2n plus 1. So indeed, we can factor it as 1 over n squared plus 1 minus 1 over n squared plus 2n plus 2. So let's write that. Okay, so we did that. Now notice that n squared plus 2n plus 2 is exactly n plus 1 squared plus 1. So let me... And so here we have one term of a series. Here we have minus the next term of a series. This is exactly a telescoping series. So let's just write it out so we can understand. So if you're not familiar with the telescoping series, let me quickly show you how it works. So here we have 1 over 1 squared plus 1 minus 1 over 2 squared plus 1. That's plugging in n equals 1. And then plugging in n is equal to 2. So 1 over 2 squared plus 1 is 1 over 3 squared plus 1. Plugging in n is equal to 3 plus 1 over 3 squared plus 1 is 1 over 4 squared plus 1. And then on and on until plus 1 over 1,000 squared plus 1 minus 1 over 1,001 squared plus 1. Now notice that here we have a lot of cancellations. This cancels with this. And moreover, this cancels with this. And this will have a next term that cancels with this. And everything inside will cancel, including this, because this will have a previous term that cancels with it. After pulling in n equals 999, this term will be exactly minus this, the negative of this, which will cancel. And this is the telescoping series, because it went from this huge sum to just the first term and the last term. So let's write this. So all this is 1 over 1 squared plus 1 minus 1 over 1001 squared plus 1. Now we still need to combine those fractions and simplify, but at least now it's much easier than what we had at the start. So this is 1 over 2. Now after evaluating this, you can think a little bit about why 1001 squared is 1,002,001. Then after adding 1, it's going to be a 2 at the end. And then we're going to combine those fractions. So this is going to be 5,010,001 minus 1 divided by 1,002,002. And now this is that. And now you can see we can simplify by 2. So we'll have and I believe I simplified correctly, yes. And notice that, well, how can we know? We want to simplify it all the way down. How can we know we didn't, isn't another factor we can already simplify by? Well, let's call this k. Notice if we multiply this by 2, we'll have the exact same thing here, except this one will be a 0, meaning that this is 2k plus 1. And so basically, if they don't have any other common factor, well, that means that they're supposedly co-prime. We want to actually check that they're co-prime. If they're co-prime, they don't have a common factor, so we can't simplify this fraction. So let's check it. We want the GCD of k, 2k plus 1, and we want to show that this is 1, because if this is 1, then they're co-prime and everything else follows. Now notice, we can subtract k from this twice. Something you can do with GCDs. Subtract the smaller number from the larger number. So I'll have GCD of k, then we'll have 2k plus 1 minus k is k plus 1. We're able to subtract k again, and we'll have just 1 left here. But GCD of any number and 1 is just 1. So indeed k and 2k plus 1 are co-prime. So these are co-prime, they don't share a common factor. So we can't simplify this fraction any more than we already did. Meaning that this is our final solution. 250,500 divided by 501,001. And finally, that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting problems and things like this in the future. And finally, that's it.